Okay, we're going to move on to some problems that are just a little bit more difficult. Reaction orders for reactions with multiple reactants. The rate is going to be equal to K times A to the N times B to the M, where N is the reaction order with respect to A and M is the reaction order with respect to B. The overall order is the total reaction orders for all reactants. It's just going to be N plus M. It's important to recognize this part. It's on your notes, but I want you to make sure you mark it, that you understand it. Okay, this is how you select experiments to compare them in order to determine the reaction order. To determine the reaction order of a substance, you have to select two experiments in which the concentration of the substance you are analyzing is changing and the concentration of all the other substances are constant. So we've got an example right here we're going to work through. Here's what, and you've got this written in your notes, but I want to walk through it with you. Okay. To evaluate the reaction order of A, so that's what this is asking us to do, determine the order of reaction with respect to A and then justify our answer. To evaluate the reaction order of A, I need to use experiments in which A's concentration is changing, but the concentration of B is constant. So we look at our experiments. My concentration of A over here and the concentration of B right here. I want some experiments where A is changing, but B is not. Reactions 1 and 2 would be a good option. Or experiments 1 and 2. Or you could do experiments 2 and 3. Or you could do experiments 1 and 3 compared to each other. In all three of those cases, A is changing, B is not. That's what's important to recognize. So the question here, to evaluate B, which pair of experiments would be selected? Well, you would be able to choose from a few of them. So 1 and 4, B is changing, but you've got 0.5 for A in both cases. We've got 1 and 5, because A stays the same, B changes. Or we could do 4 and 5 in both, and then in 4 and 5, A does not change, B does change. We want to answer part A, determine the order of the reaction with respect to A and justify our answer. We're going to use experiments 1 and 2. B is constant. Concentration of A is increased by 1.5x. And the rate is constant. Okay, so I increased the concentration of A, the rate was constant. That tells me that rate is independent of A. The reaction has to be 0th order for A, because when I changed the concentration, it did not affect rate. We're going to use experiment 1 and 4 for B, determining the order of the reaction with respect to B. Concentration of A is constant, the concentration of B is increased by 2, and the rate is increased by 2. This is the same, this is doubled, and our rate goes from 0.50 times 10 to the negative 2 to 1.00 times 10 to the negative 2. That's doubled. So rate and B are directly proportional. The reaction is first order for B. Part C asks us to write the rate law. The rate law is going to be rate equals K times A to the 0 and B to the 1. Now remember, anything to the 0 is just 1. So really our rate is just K times the concentration of B to the first power, or just K times the concentration of B. Remember, anything to the 0 power is 1. And then our overall order, that's what part D asks. What's the overall order? you just add up your orders. I've got 0 order and I've got first order. So 0 plus 1 is 1. Let's look at E. Determine the rate constant for the reaction, including the units. Start by remembering that rate is K times the concentration of B. Alright, so we've just got to plug in numbers. Rate over B is how I'm going to solve for K. I'll use experiment 1. So I'm going to put in the rate, 0.50 times 10 to the negative second moles per liter second, divided by 0.20 moles per liter, which is the concentration of B in experiment 1. Moles cancel out, the inverse liters cancel out, so I'm left with only inverse seconds. I get 2.5 times 10 to the negative 2 inverse seconds.